Hi guys, and welcome to Chapter 5, Section 5. We are going to look at something called multiple angle formulas. One thing I just want to tell you up front is the notes for today and tomorrow, they will get a little bit lengthy because it's a lot of information. They're going to tie these multiple angles into graphing sine and cosine. So thinking about those 5 key ordered pairs, you'll be drawing triangles, you'll be solving equations. Okay, so it is 2 parts. If it gets to be a lot, go ahead, hit pause, and take a break. But for today, what we are going to do is just focus on what are called double angle formulas, and they occur the most often. If you're wondering how the heck did they figure these out, there is a proof on page 405 in your textbook. And so for today, we are just going to focus on these. Now, if you have a sine of 2 theta, that is the same thing as 2 times the sine of theta times the cosine of theta. You can replace this with this, or you can go vice versa, which is kind of the cool thing. If you have a cosine of 2 theta, you actually have 3 options that work. So that's kind of fun. So depending on what you're trying to do, whether you're trying to solve, graph, or whatnot, if you have a cosine of 2 theta, you can go ahead and replace it with any of these things. And you can go in reverse. If you have a problem that is 1 minus 2 times the sine squared of theta, you can simplify it by knowing that this is the same thing as a cosine of 2 theta, and you can just replace it. Tangent of 2 theta is 2 times the tangent of theta over 1 minus the tangent of theta squared. Remember when you have your square right here, it's in between the trig function and theta. What that means is you're actually taking the tangent of theta to the power of 2. Okay, so they're going to start off with what we've been doing most recently, and that is solving equations. And so they want us to start just kind of working with these double angle formulas. So if I'm solving 2 times the cosine of x plus sine times 2x equals 0. And again, they're stating that they want us to go on that domain, meaning when we find our solutions, we're going 0 to 2 pi. It includes the 0. So we're looking at the entire unit circle to find our solutions. What the deal is here is we don't want both cosines and sines necessarily. Maybe we could end up with that, but within this problem, we do have a 2x, which is the same as 2 times theta. So if I go over here, here's that property. This is telling me that I can go ahead and replace this with 2 times the sine of theta cosine of theta, or in our case, it's an x. And the reason why I'd want to do that is because right now there's nothing, like if I try to solve this, one of the things you want to try to do is factor. There's nothing in common here. I can't do multiply add because there's not 3 terms. So I'm stuck. What I need to do is go ahead and replace sine of 2x with 2 times the sine of x cosine of x and see if I can do anything. 2 times the cosine of x plus, now here's the replacement, 2 times the sine of x cosine of x equals 0. Okay, so I hope you followed there. We had sine of 2x, that is equivalent to 2 times the sine of x cosine of x. I just replaced it. Now looking at this, I can definitely go ahead and factor. Both of these pieces, and they're separated by a plus sign, they both have a 2, and they both have a cosine of x. So I can factor out what they have in common. 2 cosine of x divided by 2 cosine of x. When you divide something by itself, remember you always get a 1. Plus, the 2 has been taken out, the cosine of x has been taken out, so that leaves me the sine of x equals 0. Now we're trying to solve, so now you take each piece. 2 times the cosine of x, and you set that equal to 0. The other piece is 1 plus the sine of x. You set that equal to 0. Now remember, when you are solving trig functions, you want to isolate the trig function. So I'm going to go ahead and divide by 2. So cosine of x equals 0 divided by 2 is 0. So this is something I can look for on the unit circle. Here I'm going to minus 1. So the sine of x equals negative 1. And again, that's something I can look for on the unit circle. You'll want to definitely keep this sheet handy for today. If I'm looking for cosine of 0, remember the cosine are the x values. So where x is 0 is pi over 2 and 3 pi over 2. Okay, so those would be 2 solutions. X equals pi over 2, x equals 3 pi over 2, because those are the locations when the x value, the cosine, is equal to 0. Now the sign, x equals a negative 1. Sign is y, the sign of x. I'm looking for the y value. There is only one spot on the unit circle where the y value is a negative 1, and that is at 3 pi over 2. We have already stated this as a solution, so you do not need to restate it. We have two solutions, pi over 2 and 3 pi over 2. Okay, we're going to look at two more like this, and then you guys, we're going to go back to graphing the sine and cosine curves, which I'm kind of excited. It was fun when I worked on it. Okay, if I look at the next one, we are working with double angle formulas. So they're going to give you like sine of 2x, cosine of 2x, tangent of 2x. Here, what they gave us is a cosine of 2x. Now, cosine is where you have choices, okay? I want to be able to factor this because I'm solving. And so for me, what made sense is I want to go ahead and use this piece because that way I would only have cosines in the problem. And if you look, this is one term. I would be replacing one term with two terms. If you have three terms, that's where you can do the multiply add method. So the first thing I did was said, okay, cosine of 2x would be the same thing as 2 times the cosine squared of x minus 1. These two things are equivalent. I still have my minus cosine of x equals 0. Now what you want to do is get this in standard form. This is 2x's, no x's, 1x's. I got to change these two. I have to rearrange it. So it's 2 times the cosine squared of x minus the cosine of x minus 1 equals 0. 1, 2, 3 terms. So it's multiply add method. There is a number in the front. So first number times the last number. 2 times negative 1. I need two numbers that multiply to negative 2. The same two numbers have to add to negative 1. That would be negative 2 positive 1 because negative 2 times 1 is negative 2. Negative 2 plus 1 is negative 1. Because there's a number in the front, these two are going to replace the middle. So it'll look like this. 2 times cosine squared of x minus 2 times the cosine of x plus 1 times the cosine of x minus 1. The negative 2 and the positive 1 replace the middle. The middle term had a cosine, so that's why I had to make sure that these also contained a cosine. 1, 2, 3, 4 terms. 4 terms, we have the grouping method. These two terms both contain a 2 and a cosine. So I can take out 2 times the cosine of x. I took the 2 out. This has 2 cosines. I removed 1, so I would have 1 cosine left. Minus 2 cosine of x divided by 2 cosine of x is a 1. I need this to match this. It already does, because cosine of x is the same thing as 1 times the cosine of x. But when you're doing the grouping method, you do have to divide something out. So here I would divide out a 1 because then it won't change the value. So this would be cosine of x minus 1 equals 0. This matches this. So my groups, I have 2 times the cosine of x plus 1. Remember, whatever you take out, that forms a group. Whatever they had in common, cosine of x minus 1, that forms a group. Now what you have to do is take each piece, and I'm just going to go on a separate sheet of paper because I don't want it to get confusing for you here. Okay, so now you take each group. 2 times the cosine of x plus 1, you set that equal to 0. This is cosine of x minus 1, you got to set that equal to 0. Now you want to isolate your trig function. So here I'm going to minus 1, then divide by 2. So the cosine of x would equal negative 1/2. That's something I can look for when I go to the unit circle. Now here I add 1. So the cosine of x equals 1. Again, this is something I can jump right to the unit circle and find those solutions. The cosine is the x value. So we have to look, where do the x's equal negative 1/2? Well, cosine is x. Negative value, I know I have to go to the left side. So negative 1/2, I have it 2 pi over 3 and 4 pi over 3. So I have x equals 2 pi over 3 as a solution. X equals 4 pi over 3 because these are the two places on the unit circle where the x value, the cosine, is equal to negative 1/2. Now I want the cosine to equal 1. There's only one place on the entire unit circle where the x value is a 1, and that's at 0. The reason why I state 0 and not 2 pi is because if you look up at our domain, remember that squared bracket means you can include it, rounded means you can't include it. So this tells us that if it ends up being at that 0, 2 pi location, you use the 0. Okay, so there was the second example. We are going to go ahead and do one more just to make sure we've got this, okay, guys? I hope you're enjoying it. It's kind of fun. Wait till we get on the back side and it gets to review. I oddly got really excited. Okay, this time, what I'm noticing is that I have my double angle where I have my 2x, it's the sine. The nice thing is when you're dealing with sine and tangent, there's not a question of, okay, which one would be the best option, because there is only one option. The sine of 2x is equal to 2 times the sine of x times the cosine of x. And this whole section is dealing with that. So I know step 1, I have to change this into my double angle formula. So it's 2 times the sine of x times the cosine of x. That replaced the sine of 2x. I still have the sine of x, and it is still equal to the cosine of x. Now here, this is all one piece, okay? This is a product. We have no plus signs or multiplication signs. So this is like sine of x times the sine of x. So I can write this as sine squared of x to indicate that I actually have 2 of them. Okay, now moving on to the next part. If you are solving an equation, remember you always want it to be equal to 0. So I have to take this cosine and minus it to the other side. So 2 times the sine squared of x times the cosine of x minus the cosine of x. Now it's equal to 0. Now I have 2 different terms. They do have something in common. They have a cosine in common. So I can divide that out. Cosine of x goes on the outside. So I'm removing this piece. I still have 2 times sine squared of x minus cosine divided by the cosine is 1 equals 0. Now I can go ahead and separate this into the 2 pieces. Okay, so I have whatever I divided out in this location or in this situation, I have the cosine of x, that equals 0. Whatever I have left on the inside, 2 times the sine squared of x minus 1, that equals 0. So guys, here's where we're at right now. I hope you were able to follow all the way along to this point. So I factored. I already have the trig function by itself, so that's awesome. So I can go right to the unit circle. The cosine is the x value. Where is the x value equal to 0? At 2 locations, pi over 2 and 3 pi over 2. So x equals pi over 2, there's one answer. X equals 3 pi over 2, there's another answer. Now here I'm not ready to go to the unit circle yet because I have to isolate the sine of x. So step 1, I'm going to add 1 over and then divide by that 2. So I'd still have sine squared of x. It would be equal to 1/2. Again, this is a minus 1, so I added. That's why it's positive here. Then I divided by the 2. This is the same as sine of x squared, the whole group. So in order to cancel the power of 2, you want to cancel the square, you have to take the square root. So this is the sine of x. Remember, even when you're doing trig, if you cancel a power of 2 by taking a square root, you have to take both the positive and the negative. When you're taking a square root of a fraction, it's the square root of the top over the square root of the bottom. The square root of 1 is 1. Square root of 2 is square root of 2. You can't leave it like this because you cannot have a square root on the bottom. You have to rationalize the denominator. So my final setup before I move on to the unit circle, I have the sine of x isolated. That's what you need. Plus or minus, because I canceled the power of 2. 1 times the square root of 2 is the square root of 2. Square root of 2 times the square root of 2 is the square root of 4, which is 2. So now the sine is the y value. So I have to go to the unit circle, and wherever the y is either a positive square root of 2 over 2 or a negative square root of 2 over 2. Those would be solutions. I'm including both positive and negative. That tells me I'm going to end up with a solution from every quadrant. So quadrant 1, where the y is square root of 2 over 2, that's pi over 4. So there's a solution. Now if I go to quadrant 2, where is the y? Some form of square root of 2 over 2? At 3 pi over 4. So x equals 3 pi over 4. Let's go to quadrant 3. Where's the y value of square root of 2 over 2? This time it's negative, but that's okay. 5 pi over 4. And last but surely not least, go to quadrant 4. Check out the y values because that's the sine. Here is my square root of 2 over 2 term, and that occurred at 7 pi over 4. So this problem, you do actually have 6 solutions, which is kind of cool. It's fun to be able to have more than one solution. Okay, so that was kind of tying it into what we've been doing recently with factoring, solving trig equations using that unit circle. Now what they're going to do, put on your seatbelt. We're going way back. They want us to graph trig functions. Just right out of the blue, they're going to be like, hey, let's go back and graph. So this is back where you are looking at those 5 key ordered pairs. But again, what they want you to do is rearrange this, make it a little bit easier to graph, get it to something familiar using your double angles formula. Now, if I'm looking at number 1, we never graphed anything with the power of 2, okay? We looked at all of our transformations, but we never had anything squared. And so knowing that, I have a cosine squared of x. Well, cosine squared of x, there's only one option. This does not have a square. This doesn't even have a cosine. So I do have to move this into a form that is cosine of 2x. I can do that by matching one of these things. So I'm going to go ahead and look. Okay, I have 4 times the cosine squared of x minus 2. Now, I do realize I could go ahead and divide out a 2. If I divide out a 2, I would have 2 times the cosine squared of x minus 1. Okay, now if you look at your double angle formula, 2 times the cosine squared of x minus 1. This is what I needed, so that way I can replace that with just a cosine of 2x. Again, you're allowed to go both ways. And this time we had to get rid of the power of 2 so I can graph it using transformations like we did at the beginning of chapter 4. I can go ahead, replace 2 cosine squared of x minus 1. That is the same thing as a cosine of 2x by the double angle formula. Now, if I take 2 times the cosine of 2x, here's my function, guys. 2 times the cosine of 2x. They want us to graph it over the interval 0 to 2 pi. Cosine starts at 1, so 0, 1. Then at pi over 2, we have an intercept. At pi, we go down to negative 1. At 3 pi over 2, we are back at an intercept. And at 2 pi, we are back at 1. So remember, it goes high point, intercept, low point, intercept, high point. And your x values are 0, pi over 2, pi, 3 pi over 2, and 2 pi. So they did not review that with us because they're hoping that you still remember that. Now here are our transformations. There's a 2 being multiplied by x. So that is a horizontal. This is going to be a compression. Because remember, when you multiply by x, you do the reciprocal. So we have a horizontal compression by 1/2. We're multiplying a 2 out front, so it's vertical. 2 is greater than 1, so it's a vertical stretch. So the way that I'm going to be changing these ordered pairs, horizontal compression, you multiply the x's by the reciprocal of whatever you're multiplying the x by in the formula. The reciprocal of 2 is 1/2. So I have to take all the x's times 1/2. Now vertical stretch, you're multiplying the y value because that's the vertical axis in your coordinate plane. You're multiplying it by 2. So I have to take 2y. So here are my new ordered pairs. 1/2 times 0 is 0. 1 times 2 is 2. 1/2 times pi over 2 is pi over 4, because remember it's top times top, bottom times bottom. 2 times 0 is 0. 1/2 times pi is pi over 2. Negative 1 times 2 is negative 2. 3 pi over 2 is now 3 pi over 4. 0 times 2 is 0. 2 pi times 1/2. 1/2 of 2 pi is 1 pi. 1 times 2 is 2. So here are the key points to get one period. So let's go ahead and graph this. I hope some of you are oddly getting really excited to do this as well. It's been a long time since we've done this and it's kind of fun. So I'm going to go ahead and say, okay, this is pi over 2, this is pi, this is 3 pi over 2, and this is 2 pi. And I do have to go from 0 to 2 pi because that's what they're telling me right here. The domain, you have to graph all the way through that far. Now looking at the y values, I have to go up 2 and I have to go down 2. My first order pair is at 0, 2. Then I have pi over 4. Pi over 4 is in between 0 and pi over 2. That's where you hit the 0. At pi over 2, that's where I'm at my minimum, which is negative 2. At 3 pi over 4, which is in between pi over 2 and pi, I hit an intercept. At pi, that's where I hit my maximum. So right now, we can see that we have the full picture of the cosine. And just going back to thinking about back in the day when we were graphing, it sounds like we're like 100 years old. So back in the day when we were graphing our trig functions, remember amplitude, here's our intercepts. Amplitude is the distance from the middle to the high point, middle to the low point. So in this case, our amplitude was a 2. Our period, the period, what that tells you is how long does it take to get the full picture. The cosine is maximum, intercept, minimum, intercept, maximum. That takes us pi. But we can't stop here because it says that we have to graph all the way through 2 pi. So I need to follow the pattern. In between are our intercepts where we had our markings. So 3 pi over 2, that would be a minimum. In between is an intercept. At 2 pi, we would have a maximum. And so that is our first example. Yes, I know it's been a while since we've done this, and that is the reason why we're going to do 2 of these guys. We're going to go ahead and graph the sine next. Yes, I know the notes are probably getting a little bit long. Again, if you need to pause, go potty, take a break and get a snack, go for it. But I did not want to just do one example and leave you there. I just feel better if we go through a couple, okay? All right, let's look at the next one. We are working with those double angle formulas. So we never graphed anything that had both a sine and a cosine, and that's because you can't. I mean, you have your key points for one or the other. We can't look at both. So I'm going to go ahead to my double angle formula. Hey, this has both. This is a sine and a cosine, but there has to be a 2 in front of it. Well, dudes, I can totally do this. I can turn an 8 into a 2. I just got to divide by 4, which is the same as multiplying by 1/4. If I divide out that 4, this would be 2 times the sine of x times the cosine of x. Now check this. 2 times the sine of x times the cosine of x can be replaced with just a sine. We know how to graph a sine function, so I can go ahead and change that. So 1/4 times the sine of 2x. Here's my new function. Isn't that cool? So these properties allow you to make alterations, kind of like, you know, wedding dresses and prom dresses. We get to alter this into what fits for what we're trying to do. Kind of cool. Now, sine function. Now, sine had 5 key ordered pairs. Again, they're different than the cosine because it's a different function. Remember, sine starts at an intercept, 0, 0. Then it goes up to the high point. So pi over 2 hit 1. Then at pi, it goes back and hits that intercept again. Then at 3 pi over 2, it goes down to its minimum point at -1. At 2 pi, at the end of the period, it hits its intercept again. So it's intercept maximum, intercept minimum, intercept. Those are our 5 key points. Now we have to change those key points to match our function. I am multiplying the x by a 2. So again, that's a horizontal compression, same as the previous example, because when you multiply by an x, that's where you have to do the reciprocal. The reciprocal of 2 is 1/2. 1/2 is less than 1. That's why it's a compression. When you're multiplying up front, it's vertical. Vertical, you keep the number exactly how it is. This is 1/4. 1/4 is less than 1. So this 2 is a vertical compression. So the way I have to change the order pairs, the x's, it's a compression by a reciprocal of 2, which is 1/2. So I have to take all the x's times 1/2. Oops, there's the x. Now the y's, it's a vertical compression. We have to take all the y values by the scale factor, and in this case, it's 1/4. So I have to take all the x's by 1/2, all the y's by 1/4, and those would be the 5 key points to see the new picture. Well, this one's kind of nice. 0 times anything is 0, so we're going to stay right at a 0, 0. Pi over 2 times 1/2, top times top, bottom times bottom, you get pi over 4. 1 times 1/4 is 1/4. Pi times 1/2 is pi over 2. 0 times 1/4 is 0. 3 pi over 2 times 1/2 is 3 pi over 4. -1 times 1/4 is -1/4. 2 pi times 1/2 is just pi. 0 times 1/4 is 0. So here are the new key points to get this picture. Again, we have to graph all the way 0 to 2 pi. Even though we just have a pi now, we'll have to be able to take the idea that this is a periodic function. And what that means again is that it just continues the same pattern as you go to the left and the right. So I'm going to go ahead and say, okay, this is pi over 2, this is pi, this is 3 pi over 2, and this is 2 pi, because we have to graph from 0 to 2 pi. My highest point and lowest point, they're 1/4. So I'm going to go ahead and say, okay, well, this is 1/2 and this is 1. This is -1/2. This is -1. So when I do my 1/4, it has to be between 0 and 1/2. So 0, 0. Bam, got it. Pi over 4 is in between 0 and pi over 2, 1/4. Da, 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 da. Here we go. Pi over 2 is 0. 3 pi over 4 is in between these two. That's where you hit your negative. Look at this. This is just like a little, it's not very high, not very low. Pi, we hit our intercept again. So from here, I can go ahead and I can figure out the amplitude. The amplitude from the middle, the intercept, to the highest points and the lowest points. I'm only going 1/4 of a unit. The period, how long does it take to see the full graph? Intercept maximum, intercept minimum, intercept. That is pi. It started at 0 and it went to pi. But we can't stop here because they want us to graph all the way to 2 pi. So I follow the same pattern. In between, I'm going to hit a maximum at the point that I labeled. That's where we have our intercepts. In between is where I have my maximums and minimums. Where I labeled, that's our intercepts. Ta-da! There is graphing sine and cosine functions using double angles. Now they're going to take us to the triangles. So here they want us to draw right triangles and be able to use the Pythagorean theorem and find the sine of 2 theta, cosine of 2 theta, tangent of 2 theta. So again, you got to keep this thing handy because when they say the sine of 2 theta, you're going to have to take 2 times the sine times the cosine. And cosine, you can pick. This is my favorite, so we're going to use this. I do think that it ends up being less work. Okay, so when we do cosine of 2 theta, this is the one I always go to. And then tangent of 2 theta. Tangent is always kind of a pain in the butt. I don't know if you've realized that, but again, tangent's going to be a little bit more work than the others because we're dealing with fractions. All right, let's do this. So if I have to draw a triangle, I have a cosine, and it's 5/13. We know cosine is adjacent over hypotenuse. Great. But before we draw a triangle, you have to figure out where the heck you're drawing it. Because when you do draw that triangle, it's within a coordinate plane. So if you picture that, here we go, I'm grabbing the unit circle. We're going from 3 pi over 2 to 2 pi. Well, here's 3 pi over 2 and here's 2 pi. So I have to have my triangle in between those two values. So I am drawing my triangle in quadrant 4. So let's go ahead and do it. Boom, 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 loop. Okay, so there is our triangle in quadrant 4 because of this. Now the cosine is the adjacent over the hypotenuse. Now I have to be able to figure out this side. Now guys, here's one thing where when we did go through this, this was like the first idea we did for distance learning. There were a couple people that made mistakes with the positives and negatives, and I'm going to go ahead and really go through that once we do the Pythagorean theorem here, okay? So when you're doing the Pythagorean theorem, remember A and B have to be the two sides that touch the 90. So this is 5 squared plus, we'll say B squared equals the hypotenuse squared. 5 squared is 25 plus B squared plus 13 squared is 169. Minus the 25 over, 169 minus 25 is 144. Now when you take the square root, you do include both the positive and the negative. Obviously, it's only going to be one. You have to figure out would it be positive or negative. This is my y value. It's going below the x-axis, so this is -12. Okay, again, that's where there were a bunch of mistakes when I looked at worksheets and whatnot. You do have to look at the coordinate plane and figure out what the value would be. This is a +5 because you're going to the right. This is a -12 because you're going down. Your hypotenuse is always positive. Okay, now let's go ahead and start doing the math. They want us to find the sine of 2 theta. And remember, theta is always next to your origin. So if I look at the formula, here's our double angle formula. The sine of 2 theta equals 2 times the sine times the cosine. So 2 times the sine of theta times the cosine of theta. So it's 2. The sine. Sine is opposite over hypotenuse. So negative 12 over 13. Cosine. Cosine is adjacent over hypotenuse. So this is what we have. Now when you're multiplying, remember it's top times top times top, bottom times bottom times bottom. This 2 is the same thing as 2 over 1. So 2 times negative 12 times 5, we end up with a negative 120. Bottom, 1 times 13 is 169. That is the sine of 2 theta. Now let's go the cosine of 2 theta. And again, I told you my favorite one is 2 times the cosine squared of theta minus 1. So it's 2 times. The cosine is the adjacent over the hypotenuse. So 5 over 13, but it's squared, minus 1. Order of operations, we're going to square this first. When you have an exponent on a fraction, it goes to both the top and bottom. So it's 2 times 5 squared is 25, 13 squared is 169 minus 1. Now you multiply. When you multiply, it's top times top, bottom times bottom. So this ends up being 50 over 169. I know I'm subtracting this as a fraction, so you have to have a common denominator. Change 1 to 169 over 169 because now your common denominator carries over. 50 minus 169 is negative 119, and you're done. Okay, let's look at the tangent. I hope you guys are enjoying this. It's kind of fun. I like having formulas. Okay, if I want the tangent of 2 theta using your rules, the tangent of 2 theta is 2 times the tangent of theta over 1 minus the tangent squared of theta. Okay, so looking at the triangle, tangent, so it's 2 times. Tangent is opposite over adjacent, so negative 12 over 5. So that is the top. I just have to take 2 times the tangent. And again, if it helps you to remember that the 2 goes with the top, go ahead and throw a 1 underneath. Now on the bottom, it's 1 minus the tangent, which we found to be negative 12 over 5. You have to square it. Okay, so the top times top, bottom times bottom, negative 24 over 5. Now the bottom, 1 minus, when you square this, negative squared is going to be a positive. 12 squared is 144. 5 squared is 25. Okay. Again, you're subtracting fractions. So we need to make a common denominator. So I need to make this thing 25 over 25 minus 144 over 25. So when we do this, if I go ahead and take 25 minus 144, I get negative 119 over 25. So I have it to here. Well, you and I both know, great, that's the property. You can't leave it like that because you can't divide fractions. You keep the top fraction the same, negative 24 over 5. Change divide to multiply. Flip that second sucker upside down. So 25 over 119. Notice they're both negative. So now when I multiply this, negative cancels a negative. When you multiply fractions, you can cross cancel. So I can cross cancel. This 5 can become a 1. 25 divided by 5 is 5. Top times top. 24 times 5 is 120. 1 times 119 is 119. So that is the tangent of 2 theta. So again, not necessarily too difficult. A lot of those algebra rules that we've been studying since Algebra 2, okay? Things like you can't divide a fraction and you can't have a square root on the bottom and simplifying, all of those sorts of things. But they just incorporated some new rules for you today. We are going to do one more because, again, the last thing I want to do is not show you enough examples where it soaks in. If you've got it, go for it. Go ahead, try some examples. But I am going to do one more just to make sure, okay? So where you draw your triangle, this says between 0 and pi over 2. So in between 0 and 90 degrees. So this triangle has to go in quadrant 1. There's my 90 degrees. There's my theta. We have sine. Sine is opposite over hypotenuse. So now to do the Pythagorean theorem, I have one leg, I need to find the other leg. So 3 squared plus b squared equals 5 squared. Well, 3 squared is 9 plus b squared, 5 squared is 25. If I minus the 9, 25 minus 9 is 16. Take the square root of each side. B is plus or minus 4. So now to figure out if it's positive or negative, you have to look and say, okay, is it going to the right or is it going to the left? We're going to the right, so this is a positive 4. So here is my triangle. Now we just have to go ahead and find sine of 2 theta. So again, that's 2 times the sine of theta times the cosine of theta. I'm going to draw a little line here so it doesn't bleed together. So the sine of 2 theta equals 2 times the sine of theta times the cosine of theta. So it's 2. Sine is opposite over hypotenuse, so 3 over 5. Cosine is adjacent over hypotenuse, so 4 over 5. Again, 2 is the same thing as 2 over 1. When you multiply, I have 2 times 3 times 4, that's 24. 1 times 5 is 25. I can't simplify that, so the sine of 2 theta is 24 over 25. Cosine of 2 theta, here's my fave. It is 2 times the cosine squared of theta minus 1. So 2. Cosine is adjacent over hypotenuse, so 4/5, squared minus 1. Order of operations. You square, you do your exponents first. So I do have my 2 over 1. 4 squared is 16. 5 squared is 25. So at this point, okay, I can already see that when I multiply this, I am going to end up with a denominator of 25. So if you want to go ahead right now and change that 1 to 25 over 25, go for it. Okay, top times top, bottom times bottom. 2 times 16 is 32. So I have 32 over 25 minus 25 over 25. Common denominator carries. 32 minus 25 is a big 7. So that's what the cosine squared of theta is. Now we have the one that's kind of a pain in the butt. Tangent. Tangent of 2 theta. Again, for your rule, it's 2 times the tangent of theta over 1 minus the tangent of theta squared. Okay, so I have 2 times tangent. Tangent is opposite over adjacent, so 3, 4. So really, if you wanted to right now, you could go ahead. I can cross cancel this. This would become a 1. This would become a 2. So 1 times 3 is 3. I'd have 3 over 2 on the top. If you like to simplify the top and the bottom right away, go for it, okay? Now the bottom is 1 minus, the tangent is 3 over 4, and we're going to square it. So it's 1 minus, when you square a 3, you get a 9. When you square a 4, you get a 16. This is the same as 16 over 16 because it's a 1. 16 minus 9 is 7 over 16. So I got it to here. Yay, sweet. Okay, but you can't leave it like that. You keep the first fraction the same. 3 halves. Change divide to multiply. Flip that second puppy upside down. Now what I can do is I can cross cancel. I can divide these two both by 2. That would become a 1. That would become an 8. Your final answer, are you ready? 3 times 8 is 24 over 1 times 7 is 7. Good to go, guys? How are you feeling? Okay, I let you have a little answer there. I know it was a lot of notes today. The cool thing is that we got to go back to graphing curves, drawing triangles, all those different things, solving equations. I know that, again, that the notes took a long time, but I wanted to make sure I did enough examples where you really did understand. Tomorrow, the notes are going to be lengthy again, okay? So grab yourself a snack, get comfy. Just kind of know it's going to probably be about 40-45 minutes, similar to today. If you are struggling with any of this, there is a Zoom call on Wednesday, and I'd love to see you jump on, and I can answer any questions that you have. I hope you guys had a great weekend, and I'll talk to you guys soon. Bye.